Okay, so I wanted to talk about the way that data travels through networks. Now, this would be a very simple explanation. There are different models for this. You have the OSI model, and you have the TCP/IP model. I will go over the TCP/IP model. I think it's easier to understand at first. They're both basically the same thing, just different ways of looking at it. Now, when we look at the how information travels through the internet, it's kind of split into five different layers. The bottom layer is the physical layer. That'll be how data actually travels through the internet, the physical medium. So if you're connected to your router through an Ethernet cable, that physical connection will be a copper wire. If you are connected, let's say you are, connected to a server down in China, well, that'll most likely be through the physical, copper cable until you hit in the between the continents where you have the underground fiber optic cables. You could also have local fiber optic cables, and then you also have different wireless communications, Wi-Fi, cellular, but just the fact that it's a wireless communication, that's all that matters. That is the first layer. The second layer is called the data link layer. Now that refers how that's basically how data is transferred between nodes. So let's say from basically from if you're going to google.com, the first node would be your router. So that'll be how data travels to your router basically. And we'll use that example from there on. Uh, your phone trying to go to google.com. The next layer is the internet layer. And let me show you actually the data link layer, what it looks like. An actual Ethernet frame is shown right here. So the way that the information travels through the physical layer is obviously through electricity or some sort of radio signal. But that information has to travel uh, through the data link layer, and that the way that it's structured is right here. So this is the second layer, which is actually uh, basically the first way that information is organized. You have destination MAC address, source MAC address. You have the actual payload, which is the information in there. You have different checks. Basically, this is how what the packet looks like at the very base level. And I have a capture of Wireshark, but I'll show that after I'm done. So that is basically the data link layer in a nutshell. So you have different ways to communicate, such as Bluetooth, Wi-Fi. Those are all the different protocols that you have here. Ethernet. Um, okay, so that's the data link layer. Um, let's continue with our Google example. So let's say you're going to google.com, you're on your phone, or you need a physical medium to connect, so that'll be wireless, and then you need a protocol. Let's say you're using Wi-Fi, right? So that'll be, let's say that's your protocol right there to connect with your router, because the first thing that you need to go is to the first hop, which is your router, and then your router will have to connect with Google server. And the way that it makes its way that way is through the internet layer. Uh, and for that, you will have to structure the information in a different way, which I have here an internet packet. And as you can see here, it has kind of similar information. It has the source address, destination addresses, and I'll give you examples of those pretty soon. You have the checksum, and then you have the actual data. So all this information is how it's structured in order for it to leave your router and go to the Google server. Obviously, it has to hop through a bunch of different routers, so it'll have to go through these two layers every time it hits a different router to get there. But basically, that's how it gets there. Now, information can travel different ways in the internet. Um, Most commonly TCP or UDP. So let's say you're going to google.com and you just want a web page. Well, you need a type of transportation to get there. If you need a web page, you will probably be using TCP, which is a reliable transfer, because you want to make sure that you get all the information, all the images and everything on that web page. But let's say you're on a phone call. Well, you don't need reliable transfer, because what's more important in a phone call is basically speed, that you get all the data as fast as possible. Because if you're on a phone call and there's a 5 second delay, it's not going to be too fun to be talking to the person. So it doesn't matter if you miss, a frame here and there, you're still going to understand the message. So it just depends how you want the information to travel. But if, let's say, you're going to google.com, you're going through a wireless medium because you're using your phone, you need to connect to your router, so you're using the data link layer to get there. Your router needs to connect to the server, so you're using the internet uh, uh, layer. And then on top of that, you need to figure out how do you want to communicate. You're going to go to a website, so you're going to use TCP to make sure you get reliable data and you get everything that you ask for. Now, the last layer is, once you figure out how you want data to be sent and all that information, then you're going to need the application layer. And the application layer basically represents how the information is sent. So if you're using HTTP, then you have different HTTP connections to basically says, hey, we're going to do images, we're going to do text. And I'll show you guys an example of this. But basically, as you can see, the information is, depending on what layer you're on, has different, this is the IP right here, packet, has different structures. And I wanted to show this how it works here. So let's say you're in a bank, you're using your computer, you want to connect to your bank, you type in your password and name. Okay, so that's your data right there, your user data. That's the application layer, that's the highest layer. So you're using an actual application. You're in Bank of America, you log in. That information has to travel to the server, right? Because it's just in your computer when you're trying to log in. That information goes through the application layer. As you can see here, the application adds its header information, so explaining like, hey, this is what's in here. Then that application layer is encapsulated, so it keeps growing. The packet keeps growing, as you can see. It's encapsulated into a TCP header, because when you're logging into a bank, you need to tell them how you want to transport the information. And TCP is reliable transfer. You want to make sure that they get every digit and every letter in your password and in your username. So you need to be reliable data transfer. So you encapsulate your application header into your TCP header, and that might be using HTTPS, I don't know, whatever they're using nowadays. And then anyways, after you have figure out how you want to transport the data, that information will need to travel through the internet. So you will need an IP header on top of that, so that it can traverse through the internet. After that, that application will need to travel from router to router, so you will need an Ethernet header. So that's another way I explained it the other way, from down up. You can also look from up down. Depends whatever's easiest for you. But ultimately, this is as big as it's going to get, is your Ethernet header. And as you can see, 46 to 1500 bytes is usually the size. Now, I wanted to show you with Wireshark. Maybe it'll help a little bit more. So I used Wireshark to capture packets. I captured HTTP, which, as you will see in the frame here, it actually has all four because it doesn't include the physical layer, different information. So this is just Wireshark. This is the packet information. This right here it's just frame information. Don't worry about that. That has nothing to do with the actual layers. The first layer obviously is the physical layer, so you're connecting. It doesn't have any information on that. It's not that important really, how it's traveling, if it's Wi-Fi or anything like that. It doesn't really matter. The next stuff is what matters. So the second layer is the data link layer, and it's saying that it's using Ethernet. So whenever I went to google.com, my computer needed to communicate with the router, right, through the data link layer. Let me show you guys right here. So here it is. So we went from the physical. I'm connected on my laptop through Wi-Fi. This is the data link layer. So this is how my computer is trying to connect with the router. And as you can see here on the packet, here's the Ethernet information, and here's the data link information, here's the protocol. It's using the, here's the 48-bit MAC address of the router, and here's my MAC address of my computer. So it's trying to make a connection, as you can see right there. Once that information is sent, the actual IP protocol will need to be established. There's a lot that goes into this. I'm just going very simply on it, because basically after I connect with my router will need to connect with the Google server when I go to google.com, and it's going to need a source IP address, destination IP address, a bunch of different information, as you can see here. But anyways, that's the next part. So once the router encapsulates that Ethernet frame into an into an IP frame, or packet, I should say, the next thing is how we're going to communicate, which is the transport layer. Here it shows the protocol, transmission control protocol, and this one requires different port numbers and such, and this is all the information. Don't worry about any of that. I mean, you can look that up if you want. After we establish how we're going to transmit information, here's the actual application layer. We're using HTTP, so it doesn't look like it's secured, but whatever. And then HTTP, you have different information, my browser, my operating system, language, and all that. And then those are, as you can see, those are the 4 out of 5 in the Internet Protocol Suite. This right here is just hexadecimal information contained in the packet, and then to the right is just any kind of, I guess, readable data that it catches. So that's pretty much it. Hopefully that explained everything. I'll go over it again just briefly. I'm in my phone or my laptop. Let's say I'm on my laptop. I'm connected through wireless communication using either Ethernet or some sort of Wi-Fi or Bluetooth to communicate with my router. Once I communicate with my router will need to communicate with the actual outside internet using the internet layer, and then from there it'll need to figure out how to communicate with the server. So it'll use some sort of transport layer, usually TCP or UDP, depending on, I guess, my end goal. And then the application is the last layer, HTTP.